All right, so let's get started here. Let's welcome Max, who talked to us about video and audio with Perl and DLNA.
Thank you. Yes, so as already said, my name is Max Maischein, and I'm very happy to tell you a bit about video and audio and how we can use Perl to talk to a DLNA device. Let me first give you a short overview of the talk. First, I will explain a bit what DLNA is and what components it is made of. And then I will do some live demos with code even to show you what you can do with DLNA. And at the end of the talk, I will talk a bit about the future improvements I hope to do for my code. Before I start, a short bit about who I am. My name is Max Maischein, and I work at the DZ Bank in Frankfurt. It's the Deutsche Zentralgenossenschaftsbank. It's the central bank of the cooperative banks in Germany. And there I work in the Department of Information Management. It's not really programming, and also we don't do any media stuff, so everything you see here is more for fun and for my private amusement, not for what I do in the bank. So I still have another disclaimer. Originally, this talk was also intended to be about Chromecast, a device by Google. But as I found out after I bought the Chromecast dongle, it's not only has it a closed API, also it's a very, very slow device. And I got horrible lag when casting my desktop browser on the TV, like 5 seconds or longer in a very, very fast network. So I have to admit I lost interest in using the Chromecast device. And so it fell out of this talk as well because, I couldn't find a way to send media to it. So if you are here because of the Chromecast, I'm really sorry, but
I actually was because of this, but I must say that even the video function, the function why this device is made for, has the same fucking lag. It's like the switch, you say like tell it to switch, and it takes 2-3 seconds till he switched finally, or volume or something. It's unbelievable how this device can actually be sold by Google.
I was like you, I was disappointed, and if I am disappointed with a toy, I don't play with it anymore. So sorry again, but the upside is it's actually not hard to implement your own Chromecast device, as I found out afterwards. With a little bit of JavaScript and an HTML page and the Chrome browser, you can implement your own Chromecast. And I have such a little script, but if we have time at the end of the talk, I will show it to you. Now, to the main point, what is DLNA? DLNA stands for Digital Living Network Alliance. It is the attempt at a standard by Samsung, Sony, and other TV producers to provide a standard so you can render your media files from your hard disk, your USB stick, or your Blu-ray drive on your big TV. That's the main idea. And the components are basically a remote control and the media renderer, which is your PC or your projector, and the media server, which is your home server where you store all your TV episodes and whatever, or Netflix. And all these devices talk to each other by using HTTP. The remote control talks to the media server for finding interesting files. And then the remote control also talks to the TV, play this URL or play that URL. And in the end, the TV talks to your media server for actually getting the data and then displaying it on the screen. And yeah, the ideal goal is obviously to replace or to implement at least the media server and the remote control by programs written in Perl, because I like to switch channels from the command line instead of pulling out my phone or starting an app to watch YouTube videos on my big screen or whatever. I want to do this from Perl. That's about it. What components get actually sold on the market? Well, you most likely have a DLNA capable TV, any smart TV that's manufactured and has a network port or a Wi-Fi card. It most likely speaks DLNA. And yeah, the TV is a rendering device. The PlayStation 3 also is a media server, but yeah, the PlayStation 4 doesn't have this feature anymore. I don't know why. There are some cable modems or DSL modems that also can act as media server. There is the Squeezebox, maybe you still know that name. It's now sold by Logitech. It's written in Perl and is a media server. And there also is the Twonky media server. And yeah, the thing that I will be using for demoing is the XBMC or Kodi, how it now calls itself. It's a media server that exists for Windows, well, media server and media renderer that exists for Windows and Android and also for the Raspberry Pi. So yeah, it's open source and actually it works on many platforms. Now, how do all these devices find each other? It works in two stages. First, there is device discovery. This is done using UPnP, Universal Plug and Play. And then the transport, as I already said, is simple HTTP. And yeah, in my programs, the remote control simply sends a UDP broadcast. Is any device here capable of rendering? And yeah, then the media renderer and the media server respond with, yes, talk to me using HTTP at this address and this port. And yeah, then we can see what happens. A first bit of code. This simply uses the module DLNA device in line 4 to find all available media renderer devices and then prints the friendly name like your TV and the manufacturer of the device just for identification. And if we run this code, it will take a while because the devices have a timeout of 5 seconds until they need to respond. And yeah, we see that on my laptop there is XBMC running, and XBMC identifies itself as media renderer. So yes, we can render videos on this laptop. Now, after we've found the appropriate devices we want to render to, we now need to tell the device what to render. And yeah, we simply, we obtain from a media server the URL of our movie and then send that URL again by HTTP request to the media renderer. And yeah, the media renderer then requests that URL from the media server, and that's it. It plays the movie or whatever. And yeah, my motivating goal was to watch HD YouTube videos on my TV, because my TV only has some weird YouTube application that is hard to navigate, and I have to enter the search keywords through the number remote control. So yeah, it's really not fun, and it doesn't render HD. So yeah, this should be fairly easy. With Perl, I make a request to YouTube. find the real stream URL, then send that stream URL to the TV, and the TV talks to YouTube, fetches the video, and renders it. That sounds very easy, and yeah, it sounds very easy, but it's surprisingly nasty, because my Samsung TV does not want to talk to addresses outside of the network segment. It doesn't request anything outside of 192, 168, whatever. And Samsung really wants some special HTTP headers that nobody else sends. And it also doesn't like the content type of video MP4V. Instead, it wants MP4V, but YouTube sends video MPEG-4 as the content type. So, yeah, but as far as I see, this is not a problem only with Samsung, but every TV or every media renderer is bad in that way, that their HTTP clients and renderer implementations are very special and need special parameters and everything. I know this because I looked at the patches for Twonky, and they have huge configuration files for every TV, like rewrite this header to that, add 10 seconds here, transcode this format to that format. Yeah, so I restricted myself to implementing it for my TV because, well, I want to watch videos on my TV mostly. And first I want to get it to work on my Samsung TV and then maybe take over the world, not everything. So this very simple diagram here becomes a little bit more complicated because I need to put a small rewriting proxy in between the TV and the internet, and that small proxy here rewrites the content type header. It adds special headers for Samsung and does some other things, and then after it has rewritten the headers, it simply loads data from YouTube and pushes the data to the TV. We initialize that proxy with a remote URL. We create a local URL and give that URL to the DLNA device. And then that DLNA device comes back to us, says, please give me the data for that URL. And then we request the remote URL, rewrite the headers, and then finally we can watch the content of YouTube. So the next script implements device discovery, as we've already seen, then remote control of a DLNA device, and also the nasty rewriting of the headers so that the Samsung TV is happy. The lines 4 to 7 are just again the lines 5, 6, and 7 start up the media server, which is the rewriting proxy, and we give it the URL we want to serve. And then we find an available device on the network, print out the name of the device, and then we start the playback by telling the renderer device, please go play this URL. That device comes back to us. I have this URL, can you give me the data? Then we fetch the outside data, and the movie gets rendered on the TV. And I really, really hope that the network is still up, because I will try an outside request on the internet.
To the stream of this conference now, of this live room?
Exactly this. Thanks to our sponsors, we have a live stream, and we should now see breakdown of the, yeah, well, it works on my TV, my PC here. Yeah, it's,
Hold it up, hold it up.
yeah, I think that's the easiest approach, as you can see here now. Yeah, there is a lag of I think 15 seconds or something more, so it's not really live, but good enough. But at least, yeah, the picture comes back up. So, yeah, I now can more or less reroute arbitrary video data served over HTTP onto my TV, which is, yeah, convenient if I want to watch movies or whatever content on the big TV without going through some other application. Yeah, if I have Perl, I can render it on my TV. Now, you didn't see it, but there was missing like the title of the talk and the expected rendering time and so on. This is because my proxy server does not yet add the expected duration of the movie or the title of the movie to the headers. That needs to be written, and also playlist handling is currently not implemented at all. And also there is not yet a proper DLNA server which also serves the cover art for music or other pretty images. There is one DLNA server that is open source and written in Perl. It's PDLNA, Perl DLNA. But yeah, I don't like the style, the coding style it is written in. It uses lots of threads, but it uses the threads on Unix. And yeah, well, I'm not really a fan of using threads for something that should be basically an event loop driven thing that just renders or moves HTTP data. So yeah, but maybe PDLNA is just enough for me. And yeah, there also needs to be a resource crawler maybe. And yeah, my next goal is to write a meta server which takes 2 or more DLNA media servers and makes them appear as one single server with a huge selection. Another idea is to just use a GoPro, which also exposes its HTTP stream, and render that on the TV. Yeah, that's it. I hope you found it interesting. Are there any questions?
Second.
I could just try and speak really loud. Can you record? Okay. My question is there any sort of handling of, you know, the stop and then pause and resume, this sort of thing?
Mm-hmm. Yeah, the question is whether the DLNA handles stop and resume. And yes, DLNA does it, but my implementation does not yet. But it's in the plan.
And another question is whether you sometimes have to do any sort of re-encoding of the stream into a different format?
Yeah, the question was about re-encoding and how necessary it is. I thought it would be highly problematic to have to do re-encoding, but I found that at least my Samsung TV plays everything. But looking at the configuration file of more generic media servers, yes, there's a huge lot of transcoding going on because this TV does not handle H.264 or whatever. So if I ever move away from just doing this for my TV, then yes, transcoding will become a major issue. There was another question.
From the remote control feature of DLNA, is it possible to switch off or switch on the TV or the device?
No, switching on or off the device is not part of it because the device needs to be on the network, and I did not find anything about magic network packets that switch on the other devices. So it's not in the standard, and yeah, my time is up. So yeah, I hope you found it interesting and find interesting ways to hack on your TV. And yeah, the code is online on GitHub already. I haven't released it to CPAN yet because yeah, there are some parts that still need work, and there's some monkey patching going on that shouldn't be on CPAN. So yeah, thank you.